Hey everyone, welcome back to our YouTube channel, the series about data engineering, data science. There is no data engineering, data science without data ingestion, so as well as about data ingestion and real-time processing. Today, we are going to discuss Fabric Spark and its exciting feature, a new feature named Native Execution Engine. This innovation transforms how we process the data with Fabric. We are thrilled also to announce the Native Execution Engine preview stage for Fabric Runtime 1.2. Joining us, our special guest, Ankita, part of Engineering Product Group. Ankita, welcome, and please take a moment to introduce yourself.
Thank you so much, Esther, for having me. So I'm Ankita, and I'm a part of the Native Execution Engine team here in India. And I'm super excited to be here and to get to talk to all of you about the engine, a few of the cool things it can do, and maybe how it can transform your workloads.
Awesome. Okay, so here for the very first time, I have opportunity to present the functionality because I'm the product manager for Native Execution Engine. So let me jump to a few slides and the discussion that we want to have about Native Execution Engine. We want to talk about the architecture, the technical details, and also about the functionality, what it's about, what performance boosts that is bringing. Let's start. So the Native Execution Engine uses technologies such as a columnar format and vectorized processing to enhance query execution performance. Our internal tests, validated by well-known TPCDS 1 terabyte benchmark, have shown fourfold speed increase compared to OSS Spark. So this performance leap is achieved by converting Spark SQL code into optimized C++ code. Native means C++ based. This is done with conjunction with Microsoft internal efforts on query optimizations with Apache Spark that has started a few years ago with Synapse, and now we are continuing that journey with Fabric. The results presented on the screen are telling us what's the impact of this query optimization effort. And now, Ankita, can you comment what, again, you are part of this team, what as a team you are bringing to Apache Spark to bring the improvements comparing open source and just Fabric Spark? We are not talking yet about Native Execution Engine. We are just talking about the milestones that we delivered between OSS Spark and Fabric Spark.
Yeah, so we've had a dedicated query optimization team who've delivered on multiple improvements. For example, features like rollup hash aggregate, cool implementations of Bloom filter, smart shuffle, and just moving a little ahead here. But the fact that Gluten operates, our native execution operates on Spark's optimized physical plan means that all of these query optimization features in Fabric Spark are also leveraged when we push execution to the native engine.
That's great. So again, now we can jump to the next steps. The next steps means the milestones delivered for Native Execution Engine that is part of Fabric Spark. The Native Execution Engine works as of now with two data formats, Parquet and Delta. It ensures that it's efficient regardless whether the data is stored in one lake or it's accessed via shortcut. It's accessed, for example, ADLS Gen 2 Azure Data Lake Storage, the second generation. So what value brings Native Execution Engine? For sure is the performance improvement in job execution. And now I want to jump into the technology that stands behind the engine and architecture. But just to give you the comment and also share the kudos and acknowledge that at the heart of the Native Execution Engine, there are two open source components. Velox, which is a C++ database acceleration library created and then open sourced by our great partner, Meta. The second part of the heart is Apache Gluten, which is in an incubating stage. That library, that effort has been initialized by our second great partner, Intel. And what Apache Gluten is doing, this is a middle layer which is responsible for offloading the JVM-based SQL engine execution to native engines introduced by Intel, so the native engine. Ankita, over to you to tell us more about the architecture that native execution engine is built on.
Yes. So as you've said, the native execution is powered by two open source components. We have Gluten and then Velox. So Gluten is a middle layer. It's essentially Latin for glue. And what it does is it glues together Spark with the underlying C++ execution. So Gluten works by transforming Spark's physical plan into a set of native operators, which are then offloaded to the native engine. Gluten has a few essential components, one of which is a memory manager, an intelligent memory manager that handles on heap and off heap memory allocations without the user needing to explicitly tune or configure these while creating a Spark session. So while Spark ran on row based execution, Gluten works on columnar batches where the underlying data is represented in the Apache Arrow data format. And to support this, Gluten has also created Columnar Shuffle Manager to support shuffle data exchange in columnar format. Gluten additionally has something known as a shim layer. So this essentially adds support for multiple Spark versions within one component because with every major and minor version upgrades, there are slight differences in the APIs and Gluten is able to seamlessly handle it. At present in Fabric, we support Spark 3.4 and there's ongoing effort to support Spark 3.5 as well. Gluten is also intelligent. While it goes through the process of transforming a Spark plan to a native plan, any operators that are not yet supported by the native engine fall back to Spark seamlessly without any failures or exceptions. And these fallback to Spark include some columnar to row and row to columnar conversions of the data. And lastly, Gluten exposes a bunch of metrics related to operations that are executed in the native engine. These metrics are all visible in Spark UI and can give you a clear understanding of where your execution speed truly comes from. And Gluten is integrated with Spark via a plugin, which is initialized in the driver and in all the executors on startup.
You've mentioned so many important elements. I want to recap that. First of all, native execution engine is available for our customers, for our users, so for Fabric data science and data engineering users. For
Yes.
runtime 1.2, we are working on
Yes.
1.3.
Yes, that's right.
Then once it's enabled, and we'll talk more about how to enable that functionality, but once you enable it, your query is going to be accelerated, boosted.
Yes.
In case if specific operation is not supported by native as of now, and we have a bunch of, we have a list of limitations in our documentation, you can be sure that the execution of the job will happen as it is as of now based on JVM.
Absolutely.
Ankita, can you tell us more about how the innovation has been built?
So, Microsoft has actively contributed to both of these open source projects, and a few of the changes that we made that were essential to our internal integration were also contributed back. So, these include the integration of Velox with the Azure Blob file system. So, this allows users to seamlessly read from data stored in ABFS, and like Estera mentioned, also data in OneLake. We also contributed the intelligent memory manager that I spoke about earlier. So I think this is great in terms of user experience because you no longer have to sit and manually handle the balance of off heap and on heap memory in your Spark job. We've also contributed a few advanced operators like broadcast nested loop join and Cartesian product, and a whole bunch of Spark functions, a bunch of timestamp functions, a few array functions, map functions. It's an ongoing list that we're continuing to contribute to. We've also added support to read timestamp. This is both int 96 and int 64 timestamp and Velox. We've added the capability to handle metadata columns in Gluten. This is particularly useful in the case of Delta. And we contributed significantly in terms of reliability while integrating with different Spark versions. We fixed hundreds of unit tests across 3.4, and we're continuing to do so with 3.5, and will do so with upcoming Spark versions as well.
That sounds great. Lots of innovations. And I love especially that we handled the memory management. So as of
Yes.
now, there are no hard-coded ratio between on-heap, off-heap memory management, but it's fluid.
Exactly. It's so seamless. All you have to do is just enable the engine, and this handles everything for you.
Now, I want to talk about the scenarios because, again, that has been said. We are supporting a runtime 1.2, which as of now, so as of end of June, it's the latest GA runtime version. We are working on runtime 1.3 to make it first of all GA and then to make it compatible with native execution engine. So that's the first qualifier. The second is if you use Parquet or Delta Lake data format. And secondly, whenever you are using a query that is not only input-output, a simple query that you read data and write, but if you use Spark to read the data, process it, transform, aggregate, sort, group by, you do lots of operations. So ideal scenarios are, for example, explanatory data analysis, the job of the data scientist who is preparing the data before starting the ML experiment. For all those scenarios, native execution engine will help you to accelerate the query execution, will basically
Yes.
boost. So let's go into how to enable native execution engine. First of all, we are working on the UI, but in the meantime, during the early stage of public preview for that functionality, you can enable it either for a single notebook or a single Spark job definition. If you put a single piece of code, a cell of code with a few Spark settings, just to enable native execution engine. This is just for a single notebook or job. But if you are using an environment item, so if you are using your own definition of the libraries, because you have to install some libraries, or just because you use environment, you can configure and enable native execution engine on the environment level. And then all the items which are associated with the environment, so all the jobs, notebooks, will inherit these settings, and all of them will be accelerated. This is a performance related feature. So I can ask a question, how to see the impact of native execution engine? Ideally, we should have two jobs, run without and run with. Compare the execution time, and you will see that with native, it should be faster. Again, based on our benchmark, the scaling, the boost was 4x. At the same time, as a user, I would love to understand if my single query has been accelerated. Ankita, how to do that?
Well, the simplest way would just be to go ahead and check the Spark plan. So you can do this either in the notebook by printing out the plan, or you can go into Spark UI and you can actually see what your executed plan was. And ideally, if the native engine has kicked in, you will see a few keywords like Velox or transformer or columnar exchange in your plan.
Or transformer, the suffix transformer.
Yes, yes.
Makes sense. And here we are working on making the stage with a name transformer. Again, transformer will indicate that the native execution engine executed the specific operation, but we are making that in a color of Fabric, so a dark blue. The change,
Yeah.
again, should be soon visible. At the same time, because this is a performance-related feature, a number of combinations, how we can use different data formats, different data types, different queries and operations, methods. The number of combinations is unlimited. We have a fallback mechanism that is helping us to be sure that, again, if the query cannot be accelerated by native because some operation, for example, delta vacuum is not supported as of now, we are working on it, but right now is not supported, then there is a fallback mechanism to JVM, so the query will be executed. Ankita, can you tell us more about fallback mechanism, how that prevent our customers to be sure that their query either will be accelerated and they will get a better performance. And in case if they will hit some limitation, documented limitation, the execution will happen by JVM.
So the key idea here is that given a query, whether all of it is supported in the native execution engine or not, the query must run and it must not fail. So we handle this very seamlessly during the plan transformation. So if a particular operation is not supported, its execution will be in JVM Spark. Now, because Gluten executes on columnar batches and Spark works on row-based batches, there is a transformation of the data from columnar to row format back to columnar so that execution can continue in the native engine if subsequent operations are supported. So this ensures a seamless integration. However, if the size of your data is particularly large, then you might hit some amount of time in the whole columnar to row and row to columnar conversions. But the hope is that the impact of the execution engine in native operations will offset any regressions that you might see in this data transformation while ensuring that the query executes seamlessly in both native and in JVM Spark.
Thanks for sharing. Now, I want to go back to the results, and that specific case has been explained and documented as part of our blog post that we have written after the announcement of native execution engine. So during the preview phase, we have run multiple one-on-one evaluations, us as a product group with our external partners and customers. One of them, the MVP, Damian Videra, he has run and designed the typical analytical queries, and he ran them, first of all, just with Apache Spark on Fabric, and then he enabled the native execution engine. We have analyzed the telemetry, but also the results coming from him. The boost was from 50 to over 300%, which is astonishing in terms of the feature that, again, as of now, there are no costs associated with the usage of native execution engine. Let's go back to the flow. As a user, I enabled native. Now I'm running my jobs, workload, notebooks with the native. I see that the execution time is faster. And then we have documented that we can control native on the query level. Why it's important, why I should do that, and when I should use that option to, for example, maybe enable for the single query or, for example, disable for a single query.
So the native engine is still a work in progress, and we do have a list of documented unsupported operations, data types, and data formats. So to ensure that you're able to use the native execution engine the best way that suits your workload, there is support to enable and disable the engine at a per query level. So in your experiments while playing around with the native engine, you might find that perhaps a particular query executes really, really fast in native engine, but a subsequent query maybe does not because it has, say, 8 out of 10 as unsupported operators. So this way you can kind of tune your workload to make the best use of the native engine while also ensuring that on the whole, you have no regressions, but only performance gains.
Ankita, thanks a lot for joining and sharing all those details. We want to make that really deep dive into the functionality, as we want to show that behind Fabric, data engineering and data science, there is a bunch of data scientists, data engineers who are working on the innovation, state-of-the-art methods and algorithms just to make the job execution faster. Right now, we are working on still one-on-one evaluation. So if you want to share your results or reach out to us with suggestions, comments, or maybe with results coming from your scenarios, please either leave the comment or reach out to me directly. At the same time, we are working on a few optimization. On the engineering side, working on Spark 3.5, so runtime 1.3. We are working on removing a few limitations. For example, as of now, native does not support manage private endpoint. So this is an upcoming sprint that we are working on. And then we'll see what is our road to making that functionality in a GA stage. We want to be sure that, first of all, it's secure, it's reliable, and brings the performance boost. Based on the results, at minimum, it must be 2 times faster, up to sky is the limit. So for those who are watching us, thanks for watching. Remember to leave the like button, leave a comment, share the video with your colleagues or someone who may benefit from watching it. And until the next time, happy exploring native C++ based execution engine for Apache Spark on Fabric. Thanks.